Good morning, class. Today we will discuss about some fundamental theorems of integral calculus under the section of definite integrals. As you know that definite integral is actually a method to calculate the area bound by the function within the given ordinates. If y equal to fx is a function which is defined and is continuous in closed interval a comma b, then area enclosed between the graph of y equal to fx, the x-axis and the ordinates x is equal to a and x is equal to b is defined as the area function, and the area function I have denoted in capital letter A of x. So it means I can say that area of x, A of x will be equal to from a to x f of x dx, where a less than equal to x less than equal to b. Means it is more or less related to what we discussed in the geometrical interpretation of limit of sum, that area function will be given by integration of a to x fx dx. Why we are saying dx? Because the area is generated on x axis and the value of x can vary from a to b. And if definite integral deals with area function, then the first theorem related to it will be, if y is a function which is defined and continuous on closed interval a comma b, and ax is equal to integral of a to x fx dx, where a is less than equal to x less than equal to b, then we can very well say that a dash x will be equal to f of x, means derivative of ax is fx for all x belonging to a comma b. Means we have studied in the previous part that the integrand is the antiderivative. The function of the integrand when integrated gives you the antiderivative. So here I am integrating fx. Fx is what? Fx is the integrand, and when you integrate the integrand you get the result, and that result is called the antiderivative. Now second theorem says that if y is equal to fx is a function defined and continuous on closed interval a comma b, and let g be the antiderivative of f. It means that d dx of gx will be equal to fx. If d dx of gx is equal to fx, so you know that integration of fx dx will be equal to gx. So it means I can say that a to b fx dx will be equal to g of b minus g of a. This is the second theorem for antiderivative, that we have to use the form as g of the antiderivative of the upper limit minus antiderivative of the lower limit. Now few things that you have to keep in mind. Suppose if you are evaluating the question on definite integral using the fundamental theorem, and if suppose we are given the function along with its derivative, like if you see the example, so what we notice that a to b phi of fx f dash x dx, means for fx the derivative f dash x dx is also present in the question. In that case, and phi is another function. So in that case what we do, we first of all go for substitution. we will assume fx as t. So if fx is t, then f dash x dx will be equal to dt. Means the function or the integrand has now been modified to phi of t into dt. Now what? The limit of the function. The limit of the function was from a to b. Means for x is equal to a to x is equal to b. Now if I have modified the function to t, the limits will also be modified. So how it will be modified? Now if x is equal to a, then t will become f of a. So we have written the lower limit as f of a. If x is equal to b, then t will become f of b. So we have written the upper limit as f of b. And then we will integrate the function. This is all about the fundamental theorem of definite integral. Thank you, class.